Welcome to my talk about intelligent encounters between machines and animals. My name is Oliver Bendel. I studied philosophy and German language and literature at the University of Constance in Germany, and after that, information science. At the University of St. Gallen in Switzerland, I wrote my doctoral thesis on conversational agents, almost a quarter of a century ago. I have been a professor at the School of Business FHNW in Switzerland for 14 years. My focus today is on information ethics and machine ethics. From these perspectives, I look at and develop robots and AI systems. First, I would like to clarify two terms in this context: machine ethics and animal-machine interaction. Machine ethics is an emerging discipline. It is about 15 to 20 years old. It is mainly concerned with giving moral rules to autonomous or semi-autonomous machines. Machine ethics is closely related to artificial intelligence and robotics. Moral machine is, like artificial morality, a technical term. Artificial morality represents only selected aspects of human morality, or you could say it is simulating human morality. I'm trying to promote the concept of animal-machine interaction. It deals with the design, evaluation, and implementation of machines and computer systems that interact and communicate with animals. Clara Mancini, a pioneer in this field, defined the term animal-computer interaction and helped to shape this discipline. My projects are not only about software and virtual possibilities, but also about physical systems. In the animal-computer interaction community, most researchers are interested in the welfare of animals. That is also my position. However, I'm aware that machines can also be used to track and kill animals. I will not go into that in my presentation. The idea of Ladybird was born in 2014. The main goal was to show simple implementation possibilities within machine ethics. Our prototype of a robot vacuum cleaner from 2017 detects ladybugs or ladybirds and other insects. It interrupts its work to prevent the suction. The Ladybird project is a project within animal welfare and machine ethics together with animal ethics. It is an animal-friendly and moral machine in my wording. Pattern recognition, motion detection, and color sensor were planned. In the end, the team only combined the robot's movement with a color sensor. In the gray box, you will find details of a paper about Ladybird. The example with Ladybird became known in the German-speaking countries. It was also suitable to explain the basic idea of machine ethics. But of course, it did not solve a big problem, although ladybugs might see it differently. Anyway, we looked for such a big problem and we found it. Worldwide, many hedgehogs die every year because of lawn mowing robots. If you talk to the manufacturers, they will tell you that you need to supervise the machine at all times to avoid such problems. But that would defeat the purpose of an autonomous machine. You use it so that you do not have to operate and supervise it. Baby hedgehogs are particularly affected because they do not run away. The time of day also seems to play a role. At night, even devices equipped with image recognition cannot react adequately. Happy Hedgehog, as the invention is called, could be a solution to this problem. Our prototype from 2019 has a thermal imaging camera that detects heat sources. Once it detects heat, it stops immediately. Then it takes a closer look at the object. This is done using image recognition and machine learning. A lamp helps with the work. If Happy Hedgehog recognizes the object as a hedgehog, it stops working until manually restarted. Let's take a look at a short video about this. I know it does not look like a lawn mowing robot, but it's a prototype. It's okay. It is moving now. A hedgehog, a photo of a hedgehog on a cup with hot water inside. Here we go. Meanwhile, industry is interested in our ideas, and prototypes and products of all kinds are being created. This robot from ENGSA, a company based near Munich in Germany, is in the tradition of Ladybird. It cleans the grass around a lake or a public swimming pool, for example, without killing insects. One company which contacted us makes larger robotic mowers for soccer fields and golf courses. Especially on golf courses, there are a lot of animals like hedgehogs, birds, insects, snakes, etc. It is important that they are not injured or killed. Another problem is related to wind turbines and the limited vision of some bird species. If wind turbines are built in the wrong place, or if certain bird species are present in this area, there is a high risk of collateral damage. Bats are also affected sometimes. DT Bird uses optical sensors to detect individual birds and flocks and can command the rotors to stop. It can classify birds using artificial intelligence. In the best case, bird species and size are displayed. Such solutions are not yet perfect. The detection of birds is getting better and better, but it usually takes too long to turn off the rotors. Let's move on to another topic, cars and animals. In 2014, we presented the concept of the animal-friendly robocar. The idea was to detect toads and hedgehogs and brake for them. Some modern cars brake for large animals, such as deer and wild boar, but they drive over small animals. A technical solution could change that. In 2016, we presented an annotated decision tree for robocar at the AAAI Spring Symposia at Stanford University. The annotations are moral justifications and assumptions. They explicitly state that the car should brake for hedgehogs and toads. This is the modeling I presented at the mentioned conference. With today's technology, it would be possible to protect small animals by a small evasive action. It helps if the car is moved up a bit. The Mercedes S-Class is capable of doing this. Of course, because of other reasons at the moment, but it could do that. It can be raised automatically and very quickly up to 8 centimeters. That could help. New prototypes and products are being developed all the time in this context. This system from India from 2018 could protect deer. It uses infrared sensors. If a deer approaches the road, the prototype uses light signals to warn the driver. Artificial intelligence could also be used to make the system more reliable and to identify certain species. But this system is simple and inexpensive. Recently, we designed a system to help bears and people in the Alps. Classic wildlife cameras, camera-equipped robots, and photo drones all play a role. Facial recognition is used to identify and track individual bears and link them to available information. If necessary, a warning is issued. Most importantly, the system will allow the bear's positions and movements to be tracked in a friendly way without the need to tag them with chips or transmitters. Let's take a look at a short video about this. Yolanda Eisenstein pointed me to a project that goes in exactly this direction. But one wants to recognize individuals of many endangered species, not only bears or wolves. I quote from the website: "Our mission is to scale wildlife research and support conservationists by providing multi-feature techniques, speed, and accuracy in animal monitoring, replacing hours of human labor with minutes of computation to combat the ongoing sixth mass extinction." Wild Me promotes the cheaper and more scalable use of photography and AI-powered computer vision to identify individual wildlife, which avoids physically tagging animals and supports public integration using imagery taken from camera traps, area surveys, social media images and videos, tourists, and citizen science. The company's founders use pattern recognition to identify, for example, whale, sharks, or zebras. In my talk, I presented some concepts and prototypes for machine-animal encounters. The more autonomous machines there are, the more animal-friendly machines we need. And the more animals are endangered, the more necessary it is to use AI and robots for the benefit. Human-centered AI is not enough, in my opinion. We need nature-centered AI. We also need more and more retreats for animals. Robots and AI systems could play an important role there as well. I explored this possibility in a paper for Frontiers in Animal Science in 2022. The title is, perhaps you're interested, Passive, Active and Proactive Systems and Machines for the Protection and Preservation of Animals and Animal Species. So that's the end. I thank you so much for your attention. This is my contact data. Please write me an email and I will answer you. I would be very happy if we could be or stay in contact. Thank you so much.